Hi everyone, today is Friday. We're going to be continuing the same work that we did yesterday, except this time we're going to be using multiplication and division to combine our like terms. Okay, so our objective says that same thing. I can simplify the products using multiplication and the quotients using division of like terms. Before we get started with today's work, let's go ahead and look at our DIN question. The review should be the same practice as yesterday. And then the preview, again, is kind of a question just for you to think about as to what we're going to be learning in this lesson. So I kind of wanted to see if some of you may be able to guess the rule that we'll be doing today. Pause your video here and get started on both of those. Alrighty. Hopefully you pause your video and now we can go ahead and look at the answers to these DIN questions. If we have 4x plus 6 minus 10x minus 7, there are a few things that we should do. Okay, first, we need to remember to use leave, change, change to create a full sum out of this expression. Okay, we don't want to be subtracting for some of the terms, but adding for others. So we'll do our leave, change, change. We'll leave any of the positive terms alone, but we'll change the operation to addition, and then just make sure to change that term to a negative as well. And then again, for this negative 7, we'll change the operation to addition, but make sure to keep that negative sign on the 7 as well. I just put mine right above it because there's not enough space to kind of squeeze it in there. Next thing that we need to do is actually look at which of these are like terms. Okay, so we can see this 4x, that has the variable x. And then we can also see this negative 10x. Okay, even though it's negative, still has the same variable. So I'm also going to box that one in. Those are like terms. But this positive 6, it doesn't have a variable at all. So that's going to be kind of a different set of like terms. And we can double check to see if there's anything that needs to be added to that. And there is one more. This negative 7 also does not have a variable. So that is a like term. Okay. If these had maybe a different variable, like a y, we could still do the same thing. Okay, so we have to look for no variable, and then each of the different letters that you may have for a variable. Now we can combine the two that are in my red boxes here. 4x plus a negative 10x should get me a negative 6x. And then a positive 6 plus that negative 7 for my green underlined terms here should get me a negative 1. I'm going to go ahead and do that same thing for number 2. If I look at some like terms, here are the two terms with x's, positive 15 and negative 7x. Here are my two terms without any variables, which makes those like terms as well. I'm going to go ahead and click my, sorry, not click my, but put my equal sign there, and then I will combine my two blue boxes here. 15x plus a negative 7x should give me a 8x. And then the negative 3 plus a positive 8 should give me a 5. Okay. For this preview question, like I said, I just want to take you a second to read through it and write down any thoughts you may have. Yesterday, we learned how to simplify the sums and differences of like terms. So we were adding and subtracting. Today, we're going to look at the product and quotient of like terms. We're going to multiply and divide instead. Okay. Think about the rule that we learned yesterday. And then think about if these types of expressions could be simplified in a similar way. What do you think? Maybe try some things and just write those down for me. When we are done with that, we can go ahead and scroll down to exercise 1. We have 4x being multiplied by that positive 3 in parentheses there. We can always rewrite expressions that look like this using our multiplication symbols if we need to. Okay. And that actually is what part A says. Expand the expression by rewriting 4x as a product. Okay, so we did kind of the first step. We wrote this, just making sure it's super clear that we're multiplying by 3. And now they wanted us to expand it just one more time. Make sure it's super clear that that x is actually being multiplied by 4 as well. Okay, so now we have the fully expanded version. Part B is asking us how we can use the commutative and associative properties to help us kind of organize the new expression before we simplify. And organize here means to kind of separate the things that we can multiply together from the things that we maybe can't multiply yet. It'd be like this variable because we don't know what the number is, right? So I could use my commutative property to change the order of these. Okay, if I want my 4 and my 3 to go next to each other, because those are some things that I can combine, then I need to change the order. This would still give me the same answer, but I'm just switching that x and 3. And then I could use my associative property to add parentheses around this 4 and 3, which tell me to multiply those two terms first. Okay. Down in part C, you're actually going to do that math. So we're going to multiply those two terms first. 4 times 3 is going to get us a 12. And then the x can't quite multiply that because we don't really know what number that is. So it'd still be 12 times x, or if we're writing it as just one term, we would have a 12x. Okay. And then part D wants you to try those same 3 steps, A, B, and C, on this new expression. So let's take a look at that. First, I want to do step A and expand this. So I'm going to have my -3 times the x. Okay, there's multiplication in there. And then times that 2. Okay, with those parentheses, that is also multiplication. Then I'm going to go ahead and rewrite this, but I want to use my properties to kind of organize it just a little bit. I want that -3 to go with that -2. So I'm using my commutative property to change the order. And then I want to use my associative property to make sure that I'm multiplying those first. My last step is to actually multiply. -3 times +2 gives me a -6. And then I still have that x variable that I can't quite combine with that coefficient. So I leave it there. Exercise 2 is going to be using those same 3 steps, but with division. Okay. The first thing that they want us to do is expand the expression by rewriting the top term as a product. So very similar to what we did in the first step here. We just want to make sure that multiplication symbol is clear between the 14 and the y. And then my division line and my 7 stay the same. Step B is asking if we can split the new expression into parts, kind of like we did in part B of exercise 1. So could we kind of put parentheses on the part that we wanted to divide first? And the answer is that we can. The way that we do that is by writing our expression sort of like this. Okay, 14 over 7, that would be one side, multiplied by y, and then we could even put this over 1 if we wanted to, is actually an equivalent expression. Okay, these two would get you the same exact answer, but by doing it this way, we have separated that 14 and 7 that we can go ahead and simplify using our division first. And when I do that, 14 divided by 7 gets me a 2. My y stays the same because I don't quite know what number it is standing for. And that would be my answer. 14y divided by 7 gets me that 2y. Part D here is asking you to use the same 3 steps, just with another example. So I'm going to show us one more time. Our negative symbol can actually go on either one of those numbers. Okay, you could put it on the top with the negative 20 to make it negative 27, or you could put it on the bottom to make it negative 9. Either way, you would still end up with the same answer. I usually put mine on top just because that's my preference. So I'm going to rewrite this as negative 27 times y, so we make that multiplication clear. And then I'm still dividing by 9. Step B is to kind of separate the parts that I can actually multiply right now. So I'm going to put that 9 only under the 27. And it's kind of like I'm multiplying by y over 1, but I don't really need to show that over 1. And then my last step is to actually divide those numbers. Negative 27 divided by a positive 9 gets me a negative 3. And then my y stays the same. Okay. Exercise 3 now is just kind of making some observations about the steps that we just did. Okay, there are going to be 2 rules that we can use that were very, very similar to our addition and subtraction rule from yesterday. And we can kind of already see what those rules are going to be, right? In exercise 1, when I was multiplying, all I did was multiply those coefficients. 4 times the 3 got me to 12, and then I kept my variable the same. Or for part D here, negative 3 times the 2 got me a negative 6, and then I kept my variable the same. Same thing with the division. Okay, we divided the coefficients, okay, or our actual numbers. 14 divided by 7 got me that 2, but the variable stayed the same. Negative 27 divided by 9 got me that negative 3. But again, the variable stayed the same. So let's try to fill in these blanks here for our 2 rules. When multiplying, we need to multiply the coefficients. Oh, whoops, clicked on the wrong space there. Uh-oh. Let me go down to my, here we go. And then keep the variable the same. I'm going to highlight these all in red for us if I can. Oh, I don't think it's going to let me for some reason, but we can fill in those blanks anyway. And then same thing with our second rule here when dividing. we just need to divide the coefficients. Oops. And we keep the variable the same one last time. Okay, I'll give you guys a second to fill those in. We have one last question to take a look at before you start the practice on your own and wrap up this page. So I'm going to scroll down here. How are these rules similar to the rule that we created yesterday for adding or subtracting like terms? By now, this should seem pretty clear, right? We only had to do the operation, whether that's adding, subtracting, multiplying, and dividing, to the coefficient, right? Only those numbers were being combined, added, subtracted, multiplied, or divided together, right? The coefficients were those numbers being combined, and then our variables were staying the same. Okay, as long as they are like terms, they both started with the same variable, we can put that on the answer as well. Alrighty, at this point, you guys should be able to try some of these practice questions for me. We have some multiplication, some division, some with two parts, multiply first, then divide, and then add them together using our rule from yesterday. And then some of them have even more, 3 parts. Some have terms that can't be combined. Okay. Just be very, very careful with what they're giving you and using those rules that we created. Then go ahead and try your exit ticket. Make sure you complete the self-reflection. And then our last thing to do for today is to complete independent practice 27 on Canvas. All right, guys. Thanks. Have a great weekend.